Okay, in this presentation we're going to look at probability, and what we're talking about here is a manufacturing company analyzing its own accident record. The accidents fall into two categories, so we have the minor accidents and the major accidents. The minor accidents are ones dealt with by a first aider, whereas the major ones are ones that require a hospital visit, and there is a different cost associated with both. $50 for the minor ones, $1,000 for the major ones. Okay, so the company has 1,000 employees, of which 180 are office staff and the rest are factory workers, which means 820. Okay. The analysis shows that 10% of employees have had an accident in the last year and 20% of the accidents are major. It is assumed that an employee has no more than one accident in a year. Okay. Just to make life simple for the question, otherwise it just gets too hard for you. So determine the expected total cost of accidents in a year. Okay. Let's just do that one first off because it gets a little bit more complicated after that. So let A be the event that you denote the event of an accident, which is something we should do at the start of an exam paper question. Just actually spell out what your notation is, okay? Don't assume that A will automatically be accident for the person correcting it. So the expected cost of an accident is the average cost of a minor or major accident times the probability of a major that it would be major given that it's accidental, okay? And then plus the average cost of a minor accident times the probability that it would be minor given that has been an accident, okay? So where do we get this? So essentially here, okay. So particularly the second line, 20% of accidents are major. That means 80% are minor, okay? So the probability of it being a major accident, given that there has been an accident, is 20%, and likewise a minor accident. So that's where this 20% comes from, and this 80%, okay? So the cost of each. So it's essentially 20% of accidents are major, 80% are minor. So essentially, you could just work it out there. It should work out to be $240 is the average cost of the accident. Okay. So we have 1,000 employees. Okay. There's a 10% chance of them having an accident, and each accident costs $240. So the total cost that we need to sort of reserve for accidents is 24,000. Okay. Now, that's the first question. The second and third question is, on further analysis, it is discovered that the member of office staff have half the probability of an accident relative to those in the factory. Show that the probability that a given member of office staff has an accident, that the probability of having an accident is 0.0549, and then we determine the probability of a randomly chosen employee who has an accident is office staff. So essentially what we're doing here is we are working with the conditional probability. That first question just required a little bit of guile and just a bit of patience and just working it out in your head. I think there's no formula for part A. I'll just go back up here. Really, I think it's actually just trying to use your intuition there. Anyway, let's proceed to part B. Let O denote office staff and F denote factory staff. Okay. Now, what we're told here is the probability of having an accident given that your office staff is half of the probability of having an accident given that your factory staff. Or if you want to put it the other way around, twice the probability of having an accident given that your office staff is equal to the probability of having an accident given that you are factory staff. Also, what we're told here, just earlier on, we're told that the probability of A is equal to 0.1. So, the probability of having an accident is the probability of having an accident and being office staff plus the probability of having an accident and, sorry, that's union there, and being factory staff. Okay, so essentially you get a big pile of accident forms on your desk. You can separate them between office staff and factory staff. Okay, now using the conditional probability formula, we can express both of those terms as the probability of A and O is the probability of A given O times the probability of O, and we are also can specify the probability of A and F as probability A given F times the probability of F. Okay, now what we could do here is make life simple for ourselves. Okay, so we know this term here. We don't know what probability of A given O and probability of A given F are yet. So we have two unknown probability formulas there, but we know that they're related to each other, equal to each other. So essentially what I'm going to do here is replace probability of A given F, and I'm going to replace it with 2 times the probability of A given O. Okay? So, little bit of calculator work. So essentially what we have here is probability of A given O times 0.18 plus 2 times the probability of A given O times 0.82. That, remember, we have 820 of our 1000 staff are factory staff. That's what that comes from. Let's go back up here and double check that. So that's what we're told. Probability, the 180 are office staff, 820 are factory staff. Okay, so essentially what we're going to do here is just rearrange this expression here. So we know the probability of A is 0.1. So we have a single expression here with one unknown. That means we should be able to solve it fairly quickly, and we should get 0.0549. The probability of the last question is find the probability of O given A. Okay, this is using the Bayes formula. The Bayes rule, I'll just call it here. Okay, and that is equal to the probability of A given O times the probability of O divided by the probability of A. Just actually, when you're just using this formula here, just say Bayes rule, using Bayes rule. Actually, I didn't really say it there, but really I should have. Just using Bayes rule, we use this. We can express it as follows. So probability of O is 0.18, and the probability of having an accident is, sorry, I got them back to front. That should be 0.1, and that means the accident here is 0.99. All right, we leave it there. So the answer is 0.099. Okay, 0.0549 times 0.18 divided by 0.1 gives us 0.099, roughly. Okay, we'll leave it there.